All right, so today we've got a real cosmic detective story for you. For decades, astronomers had this golden rule for weighing galaxies. It worked perfectly, until one day it didn't. We're going to investigate how a seemingly broken law of the universe got fixed, and in the process revealed something absolutely profound about time itself.
I mean, think about it. If you're going to map out the entire universe, you need a reliable measuring stick, right? A single, fundamental rule that just works, everywhere. But what if that rule only worked some of the time? Well, that's the massive puzzle we're diving into. So, first things first, let's meet the hero of our story, a beautiful and incredibly precise law that astronomers have trusted for decades to weigh the cosmos. It's called the Baryonic Tully-Fisher Relation, or BTFR for short. The best way to think about it is like a giant cosmic scale. On one side, you've got all the normal stuff in a galaxy, its stars and gas. On the other side, you have how fast that galaxy is spinning. The BTFR says these two things are very precisely linked. Basically, a galaxy's mass is proportional to its rotation speed to the power of 4. It's an unbelievably powerful tool.
And look, this isn't just some neat theory. It's a solid, proven fact. As the researchers say, it's a remarkably tight correlation. I mean, this rule has been tested on thousands of galaxies, from huge spirals to tiny little dwarf galaxies, and it just works with stunning precision. It was a cornerstone of astrophysics.
But of course, every good story needs a twist. So what happens when you take this rule you trust completely and try it on the absolute biggest things in the entire universe?
Okay, so let's just be clear on the scale we're talking about here. A galaxy, right? That's like one big city of stars, all held together by gravity. But a galaxy cluster, that's a whole different beast. It's like a sprawling metropolis made of hundreds, sometimes thousands of those galaxies, all bound together. We're talking the next level up on the cosmic food chain.
And you guessed it, when astronomers pointed their cosmic scale, the BTFR, at these behemoths, it just broke. Completely. The numbers came back wrong. Not just a little off, but consistently and systematically wrong. And this chart right here just lays the problem out perfectly. What you're seeing is that for the same spin speed, a galaxy cluster has way more mass than the rule says it should. It's like they're playing by two different rulebooks that look weirdly similar. And for a physicist, that's the kind of thing that keeps you up at night. It's a huge puzzle. And we're not talking about a small rounding error here. The gap was between 0.6 and 0.8 dex. Now, that might not sound like a lot, but remember, dex is a logarithmic scale. So the actual gap in mass, it was enormous, undeniable. Something big was missing from the picture. Okay, so the investigation begins. What could possibly be the missing piece of the puzzle? What could explain this huge discrepancy? Well, the answer, as it turns out, was hiding in plain sight the whole time. It was time itself. And this timeline shows you exactly why. See, galaxies are ancient. They started getting together way back in the early universe, at what astronomers call a high redshift. But galaxy clusters? They're the new kids on the block, cosmically speaking. They assembled much, much more recently. We're talking a gap of billions of years between when they formed. And that huge time gap led researchers to ask a really wild question. What if the law isn't broken at all? What if the law itself is evolving along with the universe? And this is where it gets really cool. A new theory comes along and offers this incredibly elegant solution. What do? They write time right into the equation. And here it is. This is the breakthrough. The new evolving BTFR. You can see the original relationship is still there. Mass is tied to velocity to the fourth power. But look at that new piece, that exponential time factor. That little t stands for the look-back time, basically how old the thing is. And that one little addition, well, it changes everything. It's the key that unlocks the whole mystery. So how does this actually work? It's pretty simple, really. Okay, so for galaxies, right? They formed a super long time ago, so their look-back time, t, is a big number. That makes the exponential part of the equation smaller, which means you get a lower mass for a given speed. But for clusters, they formed more recently, so their t is smaller. That makes the exponential part bigger, which predicts a higher mass. It all comes down to when the structure was born. And here's the smoking gun. Remember that weird offset we saw? That 0.6 to 0.8 dex? Well, this new theory, when you plug in the numbers for a roughly 5.2 billion year age gap, it predicts an offset of around 0.65 dex.
I mean, come on. That is a near perfect match. The theory just perfectly explains the evidence found at the cosmic crime scene.
So there you have it. With this new key, we can finally close the case. It was never two different rules. It was always just one rule. A rule that changes and evolves right along with the universe. Puzzle solved. It's that simple. Once you add in that time factor, those two parallel lines that were causing all the trouble, they just snap together. They merge into one single, beautiful, unified curve that describes everything from small galaxies to the largest clusters. And you gotta understand, the scope of this is just staggering. This single evolving law now works flawlessly across 5 orders of magnitude in mass. That means everything from the tiniest dwarf galaxies to the most gigantic clusters we've ever seen, they're all following the exact same cosmic rule. They're all dancing to the same tune.
Okay, so this is kind of the mic drop moment. How does this new idea, which is part of something called the Nexus Paradigm, stack up against the big theories? You see, the standard model of cosmology, it kind of struggled to explain that cluster offset. Other theories, like Mond, they couldn't explain it either. But this new model, it nails everything. It explains the slope, it explains the offset, and it gives us real predictive power.
So, okay, what's the big takeaway here? Why does all this matter? Well, it's so much bigger than just fixing a single equation. What we're seeing is a single rule that unifies cosmic structures of all sizes. We're seeing a direct link between gravity itself and the expansion of the universe over time. It finally resolves a puzzle that has been bugging astronomers for years. Honestly, it's a profound shift in how we view the very architecture of the cosmos.
And that leaves us with one final, kind of mind-bending question. We just watched a fundamental rule of the cosmos change over time. So it really makes you wonder, doesn't it? What other universal constants that we take for granted might not be so constant after all?